Hey everyone, and welcome to today's Explainer. Let's jump right in because we're looking at a massive, literally world-changing theme today, how we actually power the global shift to electric vehicles. We've got all these incredible futuristic vehicles rolling off assembly lines right now, but the infrastructure needed to support them, well, it's hitting some really serious roadblocks. And that brings us to, honestly, the most critical question we face right now. What happens when EV adoption totally outpaces the electrical grid? Securing enough reliable power in a reasonable time frame is fast becoming a major bottleneck for the entire green energy transition. Just think about it. You've got businesses, school districts, transit authorities buying up huge fleets of EVs, but they simply can't get connected to the grid fast enough to even use them. It's incredibly frustrating. Okay, let's dive into this. Here's our roadmap for today. First, we'll hit the EV charging bottleneck. Then we'll look at emergency vulnerabilities. From there, we'll explore some really clever mobile and off-grid solutions. And finally, we'll wrap up with AI and predictive maintenance. Part 1. The EV charging bottleneck. The grid is straining. The grid is seriously straining under the weight of all this new demand. Enterprises, public entities, massive commercial fleets, they are all facing these chronic utility connection delays. We're talking multi-year timelines sometimes, just to get the upgrades necessary to plug in a fleet of electric trucks or buses. No way you can wait that long, right? So, organizations are finding workarounds. Procurement itself can tie things up for years, but entities like National Car Charging, or NCC, and Sourcewell are stepping up. Through cooperative purchasing, they're helping over 50,000 public agencies and schools basically bypass months and months of tedious bidding. They offer a completely vetted, comprehensive hardware portfolio, from level 2 right up to DC fast charging. It's all about getting the equipment ready to deploy right now, saving a ton of time and taxpayer dollar. Part 2. Emergency vulnerabilities and uptime, the breaking point. But what happens when the grid doesn't just delay you, but actively fails you, like during extreme weather or shutoffs? If a hurricane forces a mass evacuation, a standard EV charger becomes completely useless right when people need it the most. To understand how the industry measures reliability in these scenarios, we have to look at a core metric, uptime. Put simply, uptime just means, will this charger actually work when I plug in? Specifically, it's the percentage of time a charger's hardware and software are online and successfully dispensing electricity. Now, the federal NEVI program mandates a strict 97% uptime standard. But, and this is a huge but, downtime due to natural disasters or electric service interruptions is often totally excluded from that calculation. So yeah, a charger can technically meet its uptime goals while still leaving you completely stranded during a blackout. And this brilliantly illustrates why policymakers are starting to panic a bit. When you look at the density of publicly available EV chargers across a place like California, you see these huge concentrations right in the urban centers. But if the grid goes down, that entire network goes dark. Poof, gone. This exact vulnerability is why California introduced legislation like Assembly Bill 2443. AB 2443 pushes for designated direct current fast charging, or DCFC sites, to have emergency backup power plants. The whole goal is to force operators to figure out how to keep these vital chargers running during seismic events, wildfires, or severe weather. So let's contrast our two realities here. On one side, you have the standard grid-tied charger. Fantastic for everyday use, sure, but highly vulnerable to grid failures. On the flip side, we have mobile off-grid chargers. These things are resilient, self-contained units that provide backup power instantly. When an emergency strikes, or frankly, when utility upgrades are just years away, there's a sudden and absolutely critical need for solutions that do not rely on a fragile centralized grid. Part 3. Mobile and off-grid solutions, energy at the edge. This leads us perfectly into the first part of our two-pronged fix. We're talking heavy machinery and highly flexible mobile hardware. These units act as vital stopgaps while waiting for grid connections, or they can even serve as permanent off-grid solutions. And to prove just how massive the enterprise demand is for this, check out this number, $1.8 million. That's the amount of new orders Pioneer Power Solutions secured for their eBoost mobile chargers in just the first few weeks of early 2026 alone. Organizations are literally bypassing utility timelines and throwing millions at private mobile grids just to keep their operations moving. Let's look at some super fascinating real-world off-grid success stories. In Southern California, a school district with 13,000 students and 50 electric buses realized they couldn't wait for the utility, so they brought in an eBoost mobile unit delivering 180 kilowatts of power to keep their zero-emission fleet running. Boom, problem solved. Down in Central Florida, another district transporting 52,000 students daily bought 26 new electric buses, hit the exact same delays, and solved it with mobile fast charging ports. We're seeing this everywhere. Massive utility fleets in the southeastern U.S. are charging trucks in remote off-grid locations. There's even a leading Canadian aviation hub serving 45 million passengers using mobile units to charge their airside vehicles right there on the tarmac. And this definitely isn't just a North American phenomenon. Let's shift our focus over to the Philippines. A company called AC Mobility has launched this brilliant service called Power on Wheels. They're literally bringing up to 120 kilowatt hours of mobile DC fast charging directly to enterprise fleets, commercial sites, and events. If a business runs EVs across multiple sites or is stuck waiting for permanent chargers, these mobile units just travel through the city to support them. It's a completely flexible, totally resilient ecosystem. But of course, while mobile solutions are amazing stopgaps, the permanent infrastructure still has to get built eventually. AC Mobility is tackling this through a really smart hybrid approach. They're simultaneously partnering with corporate giants like Shell and Basic Energy to build what they're calling the Philippine EV Spine. They are rapidly installing over 200 fixed charging hubs along major highways to connect destinations across the entire country, serving both everyday private drivers and electric public transport buses. The hardware innovation we're seeing right now is just moving at lightning speed to support all these off-grid and backup needs. Highly adaptable units are hitting the market constantly. For instance, you've got the battery-powered ChargeRiggs Flex 120. There's Pioneer's eBoost D, which was specifically designed to run on renewable diesel, taking advantage of clean fuel production credits. And then companies like L-Charge are offering clean fuel models that boast lower emissions than even grid-powered EVs in some regions. The toolkit for low-emission backup power is expanding so fast. Part 4. AI and predictive maintenance, the brain of the operation. So the crucial point here is that hardware is really only half the battle. AI completely transforms how these networks actually operate. It acts as the invisible intelligence, perfectly balancing out all that heavy machinery. Platforms like DriveEase are using AI to optimize the charging load across multiple stations, which prevents the grid from overloading. They can accurately predict charging demand based on things like weather, traffic, and historical data. AI even helps strategically plan exactly where new chargers should be installed, and critically, it optimizes charging schedules based on time of use rates. That means it knows exactly when electricity is the absolute cheapest and cleanest, saving a ton of money and stabilizing the smart grid. Okay, here is a statistic that will make literally any network operator's jaw drop. 30%. That is how much AI-powered predictive maintenance platforms, like those from Promwad, can actually cut field service costs. I mean, when you're managing hundreds, maybe thousands of complex electronic charging stations, slashing your maintenance budget by nearly a third while actually improving reliability is an absolute game changer. Think of predictive maintenance kind of like, fixing a flat tire before it pops. The AI is constantly collecting vast amounts of network data. It analyzes incredibly subtle anomalies, maybe just a slight temperature rise in a cooling fan or a tiny voltage fluctuation. Instead of waiting for that fan to completely break on a busy holiday weekend, the AI preemptively schedules a component replacement. It completely prevents the unexpected downtime before the driver ever has to experience a broken screen or a failed charge. And when things do go wrong, the software is right there. I absolutely love this quote highlighting Drive's capabilities. They can identify and fix 80% of charger-related issues remotely. We talked earlier about charge anxiety, right? That terrible sinking feeling an EV driver gets pulling up to a busted charger? Well, by using AI to fix 80% of software or communication bugs over the air without ever rolling a maintenance truck, operators ensure chargers actually work when drivers need them. Let's move to how this builds a fairer system, because AI also solves for equity. Right now, data shows that 40% of Americans lack access to public EV chargers. That includes 41% of suburban Americans and a massive 83% of rural Americans. Almost all chargers are clustered heavily in urban centers, but AI can analyze data to strategically place chargers in underserved areas. It can even implement smart pricing schemes that take advantage of lower rural energy demand, making charging way cheaper and much more accessible for marginalized communities. Which brings us to the ultimate conclusion of this explainer. We've seen how mobile, off-grid hardware brings power to the edge, and how AI software predicts failures and perfectly balances the load. As these two massive innovations converge, I'm going to leave you with this. Are we ready for a fully self-healing, decentralized electric grid? It's a wildly fascinating future, and it's being built right now, charger by charger. Thank you so much for joining me today, and keep exploring.